Okay, in this video we're going to look at how we can find average acceleration from a velocity time graph. So let's go back to Harry Hotter's chase from a few videos back where he's running back and forth, velocity is negative, velocity is positive, it's changing, and we want to find his average acceleration from certain points. So let's just take points A and points B. Let's say I want to find Perry's average acceleration from A to B. Well, we know that it has something to do with his change in velocity over the amount of time that goes by. So what I can do here is connect A to B and then draw my triangle here. So it should start looking like finding the slope between 2 points. From A to B, my rise is represented by my change in velocity, and my run is represented by my change in time. Don't forget your units, Mr. H. My delta t. So if I want to know his average acceleration from A to B, it's his rise over his run. In this case, my delta v over delta t, I end at 0 velocity. I start at about -7, so I go from 0 minus -7. I start at time 0, end at time 3. 3 minus 0 gives me a positive 2.3 meters per second squared. But you say, but it's a negative velocity. How could I have a positive acceleration? Well, he has a negative velocity, but it's becoming less and less negative. It's moving towards a velocity of 0. So if you're moving with a negative velocity, but you're getting less negative, you have to add positive. Okay? So positive acceleration added to a negative velocity makes it move slower, closer to 0. All right, well, what about from C to D? Okay, that's the one, right? So from C to D, again, if I want to know his average acceleration, I'm going to find the slope of the line that connects the two. Because my rise is going to be my change in V, and my run is going to be my change in T. So from C to D, I lose velocity, right? I end with less velocity at D than I had at C over the amount of time that went by. So in this case, to find my average acceleration, I end at D with a velocity of about 4. That's a D. And I started at C with a velocity about 12. So I went from 12 to 4, so my delta D is, or my delta V is -8. And the time interval is 6.5 to about 9.2. I just approximated that. So in this case, I have a negative acceleration, but my velocity is positive. Well, again, sometimes if you're moving fast and you're moving fast in the positive direction and you want to move slower, you have to lose velocity, right? So to go from a higher, faster velocity to a less fast velocity in the positive direction, you lose velocity, therefore your acceleration is negative. So the key here, well, I got this written out for you. Okay. On a VT graph, even if it's not a straight line, any curved VT graph, to find the average acceleration between 2 points, you find the slope of the line that connects the 2 points. That rise over run is the delta V over that same delta T, and that tells you the average acceleration. Okay, I'll give you a couple more sample problems to work on based on this graph. I want you to find A average from D to E and A average from E to F. So go ahead and pause the video. Okay, from D to E. All right, I'm going to connect it here. And my rise and my run, my delta V, my delta T, should be, I end at -3, I started at about 4, from 9.2 to 12 seconds, or thereabout. You should approximate these. If they're not exact, my scale, it's not graph paper, it's not the best scale, so you should approximate the best you can. it's a negative 2.5 meters per second. And then from E to F, connect these two, I find my slope, my rise, and my run. It should be about 3 minus negative 3, end at 3, start at negative 3, from 12 to about 17.5 delta t, which gives me a positive 1.1 meters per second squared. Okay, let's do a couple sample problems. Let me get a new chart up here. Okay, we have a velocity versus time graph shown below, and I want you guys to find a couple different things. First, I want you to find 4 different intervals on the graph, let's call them. So between any 2 points, so we have points A, B, C, D, E, and F on the graph, I want you, one, to find a section of the graph where you're speeding up with a positive average acceleration, where you're speeding up with a negative average acceleration, when you're slowing down with a positive average acceleration, and when you're slowing down with a negative average acceleration. So go ahead and pause the video, solve those out. Okay, so the first one, I should have left these side by side, speeding up with a positive average acceleration. So in this case, I need to be increasing in velocity, so from D to E. My delta V is getting faster, it's increasing, my velocity is increasing, and I'm going from 0 to a higher velocity, so I'm speeding up at the same time. So from D to E, I have a positive A acceleration, and I'm speeding up. From B to C, I am also speeding up, meaning I'm moving faster, right? At B, I have a velocity of 0. At C, I have a faster velocity, but it's in the negative direction, so my acceleration in that case would be negative. Slowing down with a positive, slowing down with a negative. So slowing down with a positive from C to D, if you look at that, why is my acceleration positive? Because my delta V is getting, I'm adding positive velocity to a negative velocity to move back to 0. So I'm starting at, say, negative 10. I want to get to 0, so I add positive 2, positive 2, positive 2. A positive acceleration to a negative number moves it closer to 0. But I'm slowing down because I'm moving closer to a velocity of 0. When a velocity of 0, I'm not moving, obviously. And then the final one, from A to B, in this case, I'm slowing down, let's remember what it is, slowing down with a negative average acceleration. So I'm moving at some higher velocity here, and I'm going to 0. So as I go towards the 0 line, I'm slowing down, and my acceleration is negative because I have positive velocity and I'm losing positive velocity. So my delta V in this case is going down, it's negative. Delta V goes up, it's positive. Delta V goes down, it's negative. My delta V and my delta T. Okay, a little tricky. All right, last set of questions here. B-teen, which 2 points does the object have? 1, the greatest positive A average, 2, the greatest negative A average, and 3, 0 A average. So pause it for a sec. Okay, greatest positive A average. This one's a little tricky. From C to D is a little steeper from D to E. So steeper means it's a little bit of a greater value of the slope. And then from B to C is a little steeper than from A to B. Right? So it's a little greater negative slope. And then from E to F, the line is flat. So flat means slope is 0, therefore average acceleration is 0. Okay? And that's reading and interpreting average acceleration from a velocity time graph. Tricky skill. Definitely watch this again, or come in for a little extra help, or ask me about it in class if you're having trouble understanding.